So we have discussed about two types of probability questions. Now here we'll be discussing about the third type of questions which comes in probability. That is question based on colored balls. Now these are very predominant sort of questions which are based on colored balls, and many of the times gate have asked questions on this particular fundamental in different areas, right? So let us understand the basics first. Let's say there's a box which contains 3 red and 2 yellow balls, right? Now let's say the question is asked that if a single ball is drawn at random, what is the probability of getting a red ball? I repeat, if a single ball is drawn at random from this box, what is the probability of getting a red ball? Now, I know that definition of probability of getting a red ball, you want your red ball. So it is something like the favorable number of cases upon total number of cases. So favorable cases I have is 3. So I'll have 3 red balls, which is favorable, and total I would say is 3 plus 2, that is 5. So the probability of getting a red ball is 3 by 5. Very simply. Similarly, if the question was asked the probability of getting a yellow ball, then quite evidently you can find out now is how many favorable? Yes, very correct. 2 favorable now you have out of a total of 5. So this is very simple question which can be asked. Don't expect such questions to come in your gate paper, because gate is a paper which is very conceptual, and there will be at least case of 2 balls picking in a standard paper like gate, or maybe for IAS, or for uh, any of the good level of entrance examinations where probability has been asked. So let us discuss those cases. For example, if I talk about 2 balls are picked up at random. Now supposedly 2 balls are picked up at random. So how will you find the probability of that particular thing? Now when we pick up 2 balls, so there will be 2 cases altogether, right? What will be those 2 cases? In fact, not 2 cases, but I can say 3 cases. One is called as case of with replacement. Another is called as case of without replacement. And the third one is called as the case of simultaneous picking. Right? Now, what are these 3 cases? Let me explain you one by one. Right? Now, when you talk about with replacement means from a box, I have taken up a ball. I have, let's say, a ball. There are 5 balls altogether. There were 3 red balls and 2 yellow balls. Now with replacement means I pick up one ball, right, and I replace that one ball again. Now the scenario was something like this. So I've picked up one ball, right? In the first step there was original. Second step I've taken one ball, and the third step I'm saying that I have replaced that ball. Right? So I have replaced that ball back. So this is a case of with replacement. Now, when I talk about without replacement, in without replacement, the first scenario remains the same. The first scenario remains the same. That means I'm picking up a single ball. But when I'm picking up the second ball, so I'm not replacing it back. This is, let's say, red, red, yellow, and yellow. I've kept the red ball which I picked up outside. Right? Then I'm taking up the second ball. Right? I'm talking to a question. Let's say when we are talking about two balls are to be picked up at random and both the balls should be red, right? Similar kind of a question we can discuss. For example, now if you talk about simultaneously first, so simultaneously means you are picking up both the balls together. That means this is also red and this is also red. So total number of balls remaining now will be 3, and this will be R, this is Y, and this is Y, right? So with replacement is something where we have replaced back the ball and then we are picking up the second ball. Without replacement, we have not replaced the ball and we are picking up the second ball, and simultaneously we are taking up the balls together, right? So let us see how questions can be framed out of this particular context. So number one, we will talk about, let's say a ball is picked up at random and you want to find out that then urn containing 3 red and 2 yellow balls, right, have both the balls red. Probability of both red balls. Now if I want, I can do it in 3 cases again. We talk about with replacement, we talk about without replacement, and we talk about simultaneous picking, right? So why I'm stretching this topic is because this is a very important topic from both aptitude point of view as well as your engineering maths point of view. So questions are framed on both the subjects in this particular domain. So both red, if I'm talking about with replacement. I'm talking about with replacement. So in with replacement case, when I pick up the first ball, so how many favorable cases do I have? 3. Very good. So total cases is 5. So probability becomes 3 by 5. And whenever I said that we'll use multiplication. So 3 by 5, and now I've replaced the ball back into the box or the urn, what we say, right? So I have replaced the ball in the urn. So total number of red balls now still becomes 3 and the total balls become 5. Very correct. So the probability will become 9 by 25. Getting my point now? Okay. Similarly, when we talk about without replacement, so when I'm picking up the first ball, the probability is very simply 3 by 5, right? But now I have taken up a red ball. I have kept it side. Now how many red balls are remaining? 2. Very good. And how many total balls are remaining? 4. Right? So the probability will become, if I cancel these things out, so it will become 3 by 10. Absolutely correct. Clear? What is the difference between with replacement and without replacement? Similarly, if I talk about simultaneous picking, we can take help of C, or we call it combination, where we talk about NCR is nothing but n factorial upon n minus r factorial into r factorial. Yes. So we wanted 2 balls, both should be red. So I have total of 3 red balls, out of which I want 2 to be picked up. So can I say it is 3C2? These are the favorable cases. And when we talk about total number of cases, so total I have 5 balls, out of which I have to pick up 2. So 3C2 upon 5C2. Now if you solve this, is again going to give you 3 by 10. Now you can see that both the answers in without replacement case and simultaneously case are going to be same. Now this is a trick which can be used where you can always check it out that without replacement and simultaneously in all the cases it should give you the same answer. Though they are 2 different cases, but yes, they are going to give you the same answers in every case, right? So in a paper, nobody is going to ask you the methodology. When it's option based paper, you have to just take the options, right? So even if a question is asked without replacement case, you can use it simultaneously if you're comfortable with C or combinations, and vice versa is also valid, right? Let us take another example in this same question. Let's say the second part of the question is mentioned to you that the balls are of the different colors. I repeat the question statement. Exactly how it will be looking like is a box contains 3 red balls and 2 yellow balls. 2 balls are picked up at random. Find the probability that both are of different colors. Now here again you will see 2 possibilities. Now what are those 2 possibilities is what I'm trying to say is, let's say the one ball is red and one is yellow. Is it the possibility which we are looking forward for? No. This is half part of the question. If I'm not wrong, you're guessing it correct. You can also have a probability of getting a yellow and a red ball. Now you might be wondering why I have not taken this order in the first case. See, in the first case, it was both red balls. So whether the first ball is red or the second ball is red, you are ultimately getting both red balls. But when you're talking about the second case, first red and then yellow, or first yellow and second red, makes a difference. Still, I think there is a dilemma in your mind. I'll give you a very simple analogy. Let's say I eat food first and then drink water. Or if I drink water first and eat food second, are they not two different cases? Isn't it? That is why the order is been considered in case 2 but not in case 1. Am I making sense to you guys? That is very important for you to understand that when see ultimately you are getting one red one yellow only, but when you are talking about the order, when the balls are of different colors, then order also matters and there can be two or multiple cases possible. Getting my point now? Now if you see case 1, again we have three cases: with replacement, without replacement, and simultaneous picking, right? So let us talk about this. So when I talk about this case where I'm saying that the first ball is red and the second ball is yellow, so again the probability of getting a red ball will be 3 by 5, because there are three favorable cases out of total 5 cases. And as because this is with replacement, I have replaced the red ball, so now second ball should be yellow, so yellow ball picking probability is 2 by 5. Or I'm using this or, right? Or you can say first yellow, that means 2 by 5. I've replaced that ball back, that is again red, and probability would be 3 by 5. Ultimately, whenever you will see, it will be multiplied by 2 or 3 or 4, whatever the number of cases you can form. But you have to consider that cases also. So the required probability will not be 6 by 25 as it assumed to be, but it will be 12 by 25. Now the best part is that first option will be 6 by 25 and we will get emotional and we will take up that answer. Don't do that, right? Be careful in exams. These exams are always a process of rejecting you. You know, sometimes I say my students that these exams you seems to be process of selection, but I recommend you that this is a process of rejection. They want you to get errors, they want you to commit mistakes, they want you to don't look at the small nitty-gritties of the question, and you do silly mistakes and you are out of competition. Now so many students, almost 10 lakh students taking for the gate examination, you have to understand this thing, that small things, 1 mark here and there can make a lot of difference. I've seen students struggling for that 1 mark. You know, it can change your life from IIT Bombay to IIT Roorkee to a IOCL job to an XYZ, right? Okay, let us continue with this thing. We are talking about without replacement case. Now the first red ball if I pick up, then it is 3 by 5. Now I have not replaced that ball, so the yellow ball still remains 2, but the total balls become 4. Very good. Now plus you will say now first yellow ball is 2 by 5 and this will become 3 by 4, right? If you cancel this out, 1 2 1 2, so it will come out to be, let's say 3 plus 3 6 by 10, and still you can say it is 3 by 5. Similarly, when you talk about simultaneously, now see simultaneously has already taken the consideration of order because we are picking up the balls together. So here you will say what is you want one red ball, and I'm using, that is why I'm using multiplication, and you want one yellow ball. So these are the two possible cases. 3C1 is 3 red balls and one ball you have to pick, 2 yellow balls and one ball you have to pick, and total is 5C2. Now if you still solve this will still give you 3 by 5. So you can still check it out that the answer still remains same. That is what I was talking in the last case, that the answers always remains same. Clear? So this is very important things for you to understand, that how these things can be calibrated and how these things could be used into the questions, right? Now let us move on to the one more example so that it becomes very clear to you that how this can be taken into consideration, right? Let us move on to one more examples on the same regards, right? Let me take a fresh page for that particular thing. Okay, let us say a box and on, you can say anything, right? It can be an on, it can be anything. Let's say a box which contains, let's say, 3 red ball 2 yellow balls and 4 green balls, right? And this time I'm picking up 3 balls. You are picking up 3 balls. I'll give the statement of the question. For example, the question will be something like, from a box containing 3 red, 2 yellow and 4 green balls, a ball, or not a ball, but you would say 3 balls are drawn at random such that case 1, there are 2 red and 1 green ball. Case 2, all are green balls. Case 3, all are of different colors. And the question would be, find the respective probabilities. Now, question is very clear. It's a box which contains 3 red, 2 yellow, and 4 green balls. I've just given you the statement of the question, how it will look like. So it is mentioned to you that this will be the question, right? So again, if acha, one more thing, if nothing is mentioned in the question about with replacement case, without replacement case, or simultaneously, by default you will take simultaneously. By default case is simultaneously. By default case, if you want, is simultaneously, right? So let us solve this question in all the 3 cases. I am not considering only simultaneously, I am considering all the 3 cases. Let's say with replacement, you say without replacement, and simultaneously, right? So we will get this thing in all the 3 cases so that it becomes very clear to us. We'll have 3 cases. Number 1 case was we want 2 red and 1 green ball. So am I talking about probability of getting red and green? Is it? No. Yes, you have detected very correct that this is not the only case. We can also have a case called as red green red, isn't it? Yes. Can you now determine one more case? Yes, absolutely correct. You can have green red red. Can you find out any other case? Now, see, try to understand. This red and this red are the same. See, consider the first case of the previous question. We are talking that both red does not make a difference. These red and this red will not make a difference. These two reds are the same thing. We are just interchanging. But this green will definitely make a difference, right? The position of green will definitely make a difference. Ultimately, it is going to be into 3 only. I'll say you how. See, try to understand. See, when we are talking about case of with replacement, so first ball red you are talking about is 3 by 5. Oh, sorry, not 3 by 5. In this case now, this is not 3 by 5. How many red balls do you have? We have 3 red balls, but how many total balls we have? We have 9. Okay, we have altogether 9 balls. Right? We have altogether 9 balls. So we will come back to our question and we'll say it is not 3 by 5, but 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 we will say it is 3 by not 5 but 3 by 9, right? So that is the first red ball we have got. Now with this with replacement, so we will say into second ball red, that is also 3 by 9, right? And the third ball should be green. So into how many green balls we had? 4 out of 9. Right, you can solve it. I'm not considering the solving part of it. Plus again red ball it is 3 by 9, green ball it is 4 by 9, and red ball it is again 3 by 9. Right? Plus you can also have green ball 4 by 9 into red ball 3 by 9 into red ball 3 by 9. So this will be a total probability. If you see, if you keenly observe this, these are all the same thing. See, in multiplication, if you do 2 into 5 or 5 into 2, it is always going to give you 10, right? So this is the same thing. So you can also say that it will be just multiplied by 3. Only you can find out the first case and you can multiply it by 3, right? Anyway, you can understand this thing. Okay. Similarly, we talk about without replacement case. Now, first ball should be red. So again, if I talk about red, so not we will say red probability of getting a red is 3 by 9 into probability of getting a red again. Now one ball you have replaced, not replaced, sorry, it is without replacement, so it will be 2 by 8. One ball has also reduced, right? Total balls will have also reduced. Into green, how many green we had? 4 out of how many total now remaining? 7. Very good, right? Plus in the second case you will see you want red green red, so you will say 3 by 9, that is red, into one ball you have taken out, but green balls are total 4 only, so 4 by 8 into one red ball is already gone, two balls have already gone, so total 7 balls, plus green, first green, that is 4 by 9 into it will become 3 by 9, 3 by 8. Yes, if I'm saying 3 by 9, you are also saying 3 by 9. No, boss. You have to apply your own brains. See, in a gate paper, I am not going to be there. You have to sit and solve the question yourself. Right? So 4 by 9, 3 by 8, and 2 by 7. Yes. Again, can I say this can be multiplied by 3? Yes or no? Yes or no? Yes. Now, somebody would say no. But I'm telling you, see, guys, this is 4. This is also 4. This is 7, this is also 7. See, ultimately multiplication sign is there, so that does not make much of a difference, right? And when you talk about simultaneous picking, you are having 3 red balls out of which you want 2, and you have 4 green balls out of which you want 1, and total 9 balls you want 3 balls, right? If you solve again, you will check out that without replacement and simultaneously are going to give you always the same answer. So that is the beauty of this particular thing, right? Now let us talk about the case number 2. When I talk about case number 2, what was case number 2? You want all the balls to be of the same color, and that also you want all the balls to be green color, if I'm not wrong. Let us check it out in the question that you want in the second case all the green balls. Yes, you want all the green balls. So again, if I talk about with replacement, when I talk about with replacement, without replacement, and simultaneously, so we can always say that you want all green balls, so probability of all green. Now where here will be taking the consideration of order or not? No. Yes, because whether it is the first ball which is green, whether it is the second ball which is green, whether it is the third ball which is green, it will not make any difference, right? So when we are talking about green ball, so let us say without with replacement, without replacement, and simultaneously we have talked about the 3 cases. So when we talk about with replacement case, the number one case is with replacement case, so I would say green ball. So we had 4 green out of total 9 into 4 by 9 into 4 by 9. That's it. Similarly, when you talk about without replacement, without replacement case will give you 4 by 9 into, now one ball is not replaced back, so it is 3 by 8 into 2 by 7, right? And simultaneously picking, it is 4c3 upon 9c3. That will become your answer. And if you want to solve it, you can. This will become 64 by 729. This can be cancelled out 2 times. This again gets cancelled. This 3, this gets cancelled. So it is 1 upon 21. 4c3 will be 4 upon, you can say, you know how to solve combination 987 upon 1, 2, and 3. So this gets cancelled out. This gets cancelled out 4 times, this gets cancelled out 3 times, this 4 again gets cancelled. So it is still 1 by 21. So you can still check it out that the answer in without replacement case and simultaneously case will be same. Let's talk about the third case. Will clear all your concepts now of probability. I've tried my level best to give you as much twist as possible in these particular types of questions, right? And the case 3 is saying you want all the balls to be of different colors, right? So that means one green, one yellow, and one red. So probability you want is red, yellow, green. Is it the probability you want? No. Now, yes, very smart. So you have to see the order again because the balls are of different colors. So you can have red, green, yellow, or you can have green, yellow, red, or you can have green, red, yellow. How many total cases we should get? Absolutely correct. 6 cases, 3 factorial. You know, 3 things need to be arranged at 3 places in 3 factorial ways, right? Plus. So you can also have yellow, red, green, or you can have yellow, green, red. Perfect. So how many cases we got? We got 1, 2, 3, 4, 5, and 6 cases. Right? Total 6 cases you will be getting here. Right? Now I'll find the answer in one case, and can I say it will be multiplied by 6? Yes. So now we can be smart enough and not do the labor. See, in an exam where, for example, you are sitting for a campus placement or an exam where your time domain is very important. You know, there are certain exams and competitive papers where the speed is very essential. You know, in a gate paper you have infinite time to be so called because you have 3 minutes per question almost. So there you have sufficient time, but in a very time bound paper these things will be very crucial where you have to find out some short tricks and you know you have to understand this. You don't have to do the labors, right? So when I talk about with replacement case, so first red ball, so that means it is 3 by 9. It is with replacement. So second is yellow, so it is again 2 by 9. And then it is green, so it is 4 by 9. And I know that there will be 6 cases, so I'll just multiply this by 6. Whatever answer you are getting, I'm not calculating the answer. See, in any exam like GATE, it is important for you to understand the crux. You know, it's important for you to understand the concepts rather than mugging up the questions. Yeah, answers you will get definitely once you understand the concepts. That is important. And in fact, in IITs, the professors, when you go for interviews or PSUs, they are looking actually for the concepts which lacks in some our engineering studies sometimes, right? Okay, so when we talk about without replacement case, so again it is red, which is 3 by 9, yellow will be 2 by 8, and green would be 4 by 7. And again I would say this can be multiplied by 6 as we have seen in the previous case, right? Then when you talk about simultaneously, you can say out of 3 red balls I want 1, and out of 2 yellow balls I want 1, and out of 4 green balls I want 1. So total 1 1 1, 3 balls I have picked up out of 9 balls, so total will be 9C3. Again you can check it out, cross check if you want, that without replacement and simultaneously are going to give you the same answer. So we have discussed case 3 in a very detailed manner, where we have understood that colored balls, how twisted questions can be asked on colored balls. And important part I have told you is that whenever nothing is mentioned in the question, you have to take a case of simultaneous picking. So you can put it a note, right? You can take it as a note that a case where nothing is mentioned about with replacement, without replacement, or simultaneously picking, then always take simultaneous case as a default case. Okay, you can make a note in your notebook about this particular point.